Welcome to our video on modeling variation. Our skill objective for this one is to develop models using direct, inverse, combined, or joint variations. The conceptual objectives for this video are 1. To understand the difference between direct and inverse variation, and number 2, to understand the difference between combined and joint variation. Let's look at what's called the constant of variation or the constant of proportionality. Every variation problem is going to involve a constant value that is usually represented as the letter k, and that k is that constant of variation or constant of proportionality. In a problem, you will be told how y is related to x. They'll say y varies directly with x or y varies inversely with x. This information is going to give you what you need to come up with an equation involving y, x, and the letter k, that constant of variation or constant of proportionality. In these problems, your first job is after writing down the equation, is going to be to take the given information that you have and identify the value for k. Once you have that value, then you'll be able to answer the rest of the questions in an application problem. Let's first look at a direct variation. We're going to let x and y represent two quantities. The following are going to be equivalent statements. The first one, number 1, y equals k times x, where k is a non-zero constant. That's the same thing as saying y varies directly with x, or y is directly proportional to x. When you hear y varies directly with x, that automatically means right away you should be thinking y is equal to kx. That will be the equation you're going to come up with. The other thing you have to keep in mind is that this also works with powers of x. So when I could say y equals k times x to the n, that's the same thing as saying y varies directly with x to the n, or y is directly proportional to x to the n. You will end up dealing with both of these as you go through these problems. So keep that in mind in terms of those relationships. That you're going to get in a direct variation, it's going to be the constant times x, or the constant times some power of x. One thing I want you to remember, in a direct variation, y gets bigger when x gets bigger. That relationship will always be true. So the opposite is also true, that y will get smaller when x gets smaller. Now, let's look at an example. We want to write an equation that describes the variation. Y varies directly with x squared, and y equals 2 when x equals 4. We're going to use that information to go and identify an equation. The first thing I want you to realize and notice on this one is that we are told that y varies directly with x squared. So what that tells me is that I know by the definition we saw earlier that y is going to equal kx squared. And now what we need to do is find the equation that's describing this variation, because we have this given information that y equals 2 when x equals 4. I want to use that to go and identify the value for k. Once I have that, then I will have a mathematical model for this situation. So what I'd like you to do is pause the video and identify the value of k. Please keep it as a fraction. Do not write it as a decimal. Welcome back. Let's take a look at what you get. You should have come up with k is equal to 1/8. In this case, we already know that since y varies directly with x squared, we have the equation y equals kx squared. So what I need to do, the first thing I'm going to do is I'm going to plug 2 in for y, because I'm told that y equals 2 when x equals 4. So I'll put 2 in for y and 4 in for x. That will give me 2 equals k times 4 squared, which gives me 2 equals 16k. Divide by 16, I get k equals 1/8. That then means that the equation that models this direct variation is y equals 1/8 x squared. So that would be our final answer on this particular problem, because we did have information about one point that was true, that y was 2 when x was 4. Now let's look at an inverse variation. Again, we're going to let x and y be two quantities. The following are equivalent statements. Y equals k divided by x is the same thing as saying y varies inversely with x, which is also going to be the same thing as saying y is inversely proportional to x. As was true with direct variations, the same idea exists with powers of x as well. So I could say y equals k over x to the n. That's the same thing as saying y varies inversely with x to the n, or y is inversely proportional to x to the n. Again, like with direct variations, when you hear the statements that you see in numbers 2 and 3 in both parts here, that will give you should automatically think of the equations you see in part 1 in terms of stating those. What I'd like you to do now is I've written down 4 different variations, either direct or inverse, and what I'd like you to do is write the equation for each variation. So in terms of the problem, you're not going to be able to tell me what k is, but your equation should involve k. So pause the video and write down an equation for each one of the 4 variations that are described on this slide. Welcome back. Let's take a look. I've written down the answers to each one. In that first problem, y varies directly with x to the 4th. So we have, that's just a standard, straightforward, y equals k times x to the 4th. When we have y varies inversely in number 2 with the cube root of x, I know that y is equal to k over the cube root of x. In number 3, y is inversely proportional to x squared. So that again is an inverse variation. So I know y is equal to k over x to the 2nd power. And the final one, y is directly proportional to the square root of x. Again, that's the same as a direct variation. So in this case, y equals k times the square root of x. So these would be your equations based on that information. In terms of finding k, they would have to tell you another piece of information. They'd have to say that y is equal to some value, some number like 5 when x is equal to 3, something along those lines to go through that you could plug in and then find out what k is. Another thing that will occur is you have what are called joint and combined variations. Now, the first thing you need to keep in mind is a joint variation, right here, occurs when one quantity is directly proportional to the product of 2 or more other quantities. So, an example of this type of situation is simple interest. And that's really because the interest is equal to P times R times T. Okay, so that would be an example of joint variation. The other one is combined variation. Now the difference between them, in a joint variation, it's directly proportional to the product of 2 or more quantities. In a combined variation, when you're dealing with a combined variation, that's going to occur when there is a direct variation and an inverse variation in the same problem that's occurring at the same time. So that would give you a combined variation. Okay, now often what you'll hear is they could say y varies jointly with x and y, so or x and z. So in that case, I would have y equals k times x times z in that situation. So you'll hear the joint variation in that aspect. But when you have a combined variation, they will say y varies directly with x and inversely with z. Something along those lines. So they will break it up like that. They won't say that it's a combined variation, because you wouldn't then be able to say for sure which one is supposed to be the direct and which one would be the inverse. So in a combined variation problem, they will specify that y will vary directly with x and inversely with z, something along those lines. Please remember, one thing you need to remember on this, and I stated this earlier, every variation problem will involve a constant of variation that is usually represented by k. We will always use the letter k. The book, I even think, tells you in the problems to use k as a constant of variation. In any application problem, you will need to find k before finding the answer to the problem. That there is going to be enough given information for you to identify what that k value is. So at this point, we have now completed our video on variations, modeling variations. Again, please look back. You should be comfortable with telling me the difference between a direct variation and inverse variation, and also be able to tell me what the difference between a joint variation and a combined variation. So with that, we are done with this video. There will only be this video for this next section, and this will conclude. This is our last video for the initial chapter, chapter 0. And so next class, the next class after the video, we'll go over this video. We'll do some problems with it. The next class after that will be a review day for the test, and then the test will be the following class. So we will see you in class to go over this video, and have a good evening.